So we never
It's competition now.
look, it has to offset.
Okay, you're gonna choose. And since everybody's sitting already, or not. Keep the spots on. Switch means flip the. Good. And the other one. Good. Perfect. What, you want to set these?
I think better keep that one on the spots. That's what holding in the front could
No. Why? I don't know. Just otherwise you fall asleep. You can shut. It's fine. Svi, shut these spots. No. Yeah. Oh, too dark.
Too dark?
Too dark. Yeah. Svi,
I'm gonna fall
back
asleep.
up. Perfect.
Great job, Steve.
TK.
It's too boring. I'm gonna fall asleep with the lights off. Because why?
All right. What's the reason?
Let's get started.
All right. You're putting this on? How's this working?
I don't know. I guess.
Ellie. He's supposed to clip this. No, this is supposed to clip on?
What? Clip it on your sweatshirt. And keep this in your pocket.
If you want to like walk around.
Sure.
Good evening. Hello. Welcome. Thank you all for coming. First off, I'd like to say thank you to Mr. Ellie Golding and Svi Gershbaum for upgrading the menu tonight. If you have any feedback regarding the food or drink, foodback, yes, thank you. We have developers in the room, yes. If you have any feedback, please feel free to reach out via Slack, Meetup, or however else you know how to. It's good food. All right, there you go. Well, if we keep up this food, then we're gonna have to start asking for donations. No, I'm kidding. In any case, I'd like to also thank, before introducing, Heshi over here for stepping up when we had a last-minute cancellation. We hope to have the meetup that was scheduled originally for tonight, be rescheduled. It will be rescheduled, Hashem, either next month or the following month, hopefully. I mean, I don't want to say anything for sure because we don't have any confirmation yet. In any case, thank you all for coming and continuing to make this meetup the success that it is. And without further ado, we'll get to hear from.
Thank you. Does this work? Yeah, it's good. Fine. Yeah. All right, yeah. So if you're coming here expecting Dr. Yanovsky, I'm also disappointed I'm not him. But this is what I have available on like 2 days' notice. So C# 8 is coming. Even if it's not so negative because you're not doing C#, there's still maybe some language stuff that you might find interesting. So it's coming. Microsoft says, when is it coming? It's coming beginning of 2019, which means like tomorrow or July. Any time in between is the beginning of 2019. Yeah. So, but these aren't featured future features. These are present features. These are things that you could pick up right now, that you could experiment with. So when it comes out, when the RTM bits come out, you could you'll know what to expect. Some of the things that you can ignore, but I'll point out things that your code's gonna possibly break if you do. All right, so the first thing is nullable reference types. That's the biggest headline that everybody's talking about. So you're going to tell me that we were able to set reference types to null right when the language came out. I mean, that's pretty much the definition. So what's the big chiddush over here? Okay, so you were able to, until now, to go ahead and, if you have a reference type, go ahead and set that memory value to null. But now, if you want to do that, so you're going to have to go ahead and say that that's what you want to do. If you don't, so then the compiler is going to start giving you warnings, and this is an opt-in thing. So if you opt in and you set your reference type to null, it's going to yell at you. But by default, they're going to, if you don't say otherwise, they're going to opt you in. So if you do like a new project, then you'll be opted in, and so then you're going to go along and do things the way you've been doing till now, setting your reference types to null, and it's going to start yelling at you, and now you'll know why. All right, so this is So this is maybe when the 1.0 so it came out. So I have a reference type over here, some complex object, and I'm going to get from somewhere else. I'm going to get it, set it equal to this guy, and then use it, right? But if you do this today, then it's going to tell you that this is well, without it. So if you try to use it, it'll tell you that it's possibly that you didn't set the reference. So you do this, set equal to null, right? So this is what you were able to do till now. Okay. So before you go ahead and use it, you'll have to go check to see that what came back over here is not null, because you can't use nothing. So if you try to take null and dereference it, right, you try to do, it's going to tell you that this is a problem, right? So you can't if this is null, you can't take an uppercase of something that you don't have, right? So you have to check it over here. This is, but until recently, you would do a not equals null. This is the preferred way to do it now. At any rate, we're getting there. Yeah. So that was till now. But for now, so from now on, if you want this to equal null, so you actually have to go ahead and, just like you had with nullable value types, like ints, you had nullable ints. Now you have to say, well, these are nullable objects. Okay, so you have to say, I know what I'm doing. I know that I'm setting it equal to null. And I know that I'm going to test it to make sure that I'm not using it later on. Okay, so that's the big change over here. That and TypeScript had things like this. So lots of other languages. Now C# is bringing this in as well. That if you want to set an object equal to null, you have to say, yes, I know what I'm doing, and that's what I want. It isn't an accident.
Can it not become null otherwise?
What?
It's not able to become null otherwise?
If you set it equal to null, so then it's going to, the compiler is going to yell at you. So
The
it's
existing code can no longer be set to
Should not. I won't say cannot. And even with this, there's lots of ways to go ahead and to trick the compiler, because the compiler can't really know everything. Like who knows what's coming in from here, right? So the compiler, you could confuse the compiler. It's possible. There's a whole list of known things. But at least you're saying I'm aware of this, and I won't have a null reference exception sneak up on me, right? So that's what we're testing over here. Now we say that we're doing this with knowing what we're doing. So maybe you're getting to the Elvis operator here. Looks like his haircut. That's why it's called the Elvis operator. That's the official name, the unofficial name. Anyway, so that's what we're doing over here. We're saying if it's null, this is already existing. This is not C#8. This is like 6. If this is null, so then don't dereference it. So you won't get a null reference exception. So instead, you'll just return null in here instead of blowing up. So a string with a null value, that might be perfectly acceptable. It means you don't have anything, and so don't display anything. But you don't want to go ahead and take an uppercase, take the uppercase of nothing, because then it will blow up. So this is what's currently existing. What's coming, very possible. This is not definite, but what is very strongly possible coming is what TypeScript have, other languages have, which is the darn it operator. That's not really what it's called, but my kids might be listening to the thing. And this says like, I really know that it's never ever going to be null. So just listen to me, and darn it, put it just go ahead and do this. So why would you want to do one over the other? Like this would work too, right? But if you get a little bit more, the compiler goes ahead, and this is like syntactic sugar, and it'll throw all the null checks over here behind the scenes for you. So this way, this instead of you typing in you're complaining every single time, so the compiler will do it for you. Here, the compiler won't do it for you. The compiler will trust you, and so you get a couple of more cycles of. And
what happens if it's actually null
in this case? Then you get a null reference exception.
So just skip it. So just skip it. Just say get to upper.
Oh no! This at least now the compiler won't yell at you. You're telling the compiler. This is like this now is like this before. So you're telling the compiler with the exclamation mark, I really know what I'm doing. Just listen to me and let me do this, because I know for a fact that this can never ever be null.
So now, let's say you don't put anything. It's the same thing as putting an exclamation mark?
Exactly. So the exclamation mark is just to tell the compiler, trust me, I'm a developer. I know what I'm doing. All right. So that's the whole null reference thing. All right. Just a quick thing that you can ignore this, but this is just a lead-in. So I'm sorry. This is you can't ignore this. This is another big important thing. Default interface implementations. Okay, so classic interview question is what's the difference between an interface and an abstract class, right? Okay, so there's lots of ways to answer this interview question depending on like what the job is that you're going for, or how much you want to impress the interviewer. So from a high level architectural answer is that an interface is a has a, and the class is an is a, right? Like a truck is a vehicle, a car is a vehicle. They have 4 tires, right? A car isn't 4 tires, a truck isn't 4 tires, but that's something that like I can guarantee that I have 4 tires, and if it's an I-wheeled, so then I know that I'll have a rotate tire thing on it, right? So that's the IEnumerable. IEnumerable, it's not. It's what is it? It just tells you that I can iterate on it. It tells you that there's one function that's guaranteed that it will provide getEnumerator, which then is also an IEnumerator, which then gives you a move next, clear, and give me the current one, right? Those three things. Very simple. Doesn't tell you what the structure is. There's no implementation on it. Doesn't tell you if it's a linked list, if it's an array. Doesn't tell you how the memory is laid out. Doesn't tell you what if there's a guy like standing there putting the donuts on the conveyor belt. If it's automatic, it doesn't tell you anything about it. It just tells you that you can move to the next thing, right? So that's the INumerable. It is not a thing for itself. It just tells you that it has a let's move on. Okay, so that is conceptually the real big difference. Is the class, on the other hand, that is something, right? And so then that's going to provide you something more concrete later on. And that's the big difference, was that the interfaces didn't have any actual implementation. It just told you somebody else guaranteed is going to provide this for you. So like somebody will, I'm just an INumerable. Somebody will later on will say how to go ahead and move to the next piece and keep on getting more of them. But so that is one difference. So another difference is multiple C#. Is that Java is different than C++. But anyway, I can have multiple interfaces because a truck can have an engine, a truck can have tires, right? So I can have like lots of different things that I can do with this. But multiple interfaces, but only one class that it can inherit from, right? Single inheritance, multiple interfaces. So that's another way to answer it. Another answer is that classes, so abstract classes can have a default implementation. The interface, like we said, doesn't have any. Why would you want to use one over the other? So like it all depends on like so one of the drawbacks is that if I use if I have an interface, then the interface, we said, guarantees that something is going to implement the interface. Yeah, so I can't change it. I can't add to the interface, because if I say now that if I add stuff to it, so then now the old code that says that they're going to implement this interface, now they're no longer doing it. You just broke it, right? I don't know. Maybe if I have in our tire case, so I have the rotate tires. Maybe I want to have add a fix a flat. So the old code that's inheriting from that is implementing this interface all of a sudden stopped implementing that interface, and it won't compile for you anymore. So that is a big difference. So what does it look like? So that's what it looks like. A lot of problems with that. The whole thing is going to explode if you're not careful. So here is practically an example of what can happen. So I have an iLogger. It guarantees that I'm going to have that whoever implements this interface is going to give me one of these, right? Now, if I decide to expand on it, to add something to it, well, this guy no longer implements it anymore, right? So it's going to explode. So what they decided was they're going to go ahead and now let you have a default implementation. So the old guys will still compile. They'll just use whatever default implementation is satisfied. You could even just return nothing, right? But now it won't blow up. There's lots of problems with that, though. Is that this is you can make an end run around multiple inheritance now, right? Because I can have lots of interfaces with now implementation with actual code behind it, and then we're back to all the problems that they tried to get away from in C++. So if you don't stand there with a whip, you can have developers that can like really mess things up with this new feature that is coming along, right? I mean, it breaks things on so many levels. It breaks things on architecture. On the architecture level, is that horrible, right? Awful, right? I know. If only you could opt out of this, right? But it's coming in the language. So this is no longer an is and has a, right? Yeah. Okay. We only have. Yeah, no, we only have like another half an hour or so till now. Exactly, it's not a contract. What? Yeah, or you could go gripe on the interview. I don't know, but there's lots of, if you're not careful, there's lots of problems that this can cause. So
the potential for abuse you're talking about is deliberate, right? It's not
or you don't know what you're doing. So it's possible.
Deliberate. I mean,
It's you could do it deliberate if you're devious, if you're right, but you could.
Let's say I decide to implement the interface, right? But they're not forcing you to implement any of the new functions, any new methods that they add.
They view that as so Mads Torgerson says that's yeah, he say they view it as a positive thing, right? Because now we're not forcing we can add stuff to it. It's easy to change, right? So anyway, there's lots of ways to get around it until now, right? I mean, we've been going for many years with things just the way they are.
Just so we don't want people to recompile their code. I mean,
Yeah. Right. No, it's not just recompiling. It won't recompile. You'll have You'll have to go ahead to go through all the code,
throw no implemented exceptions or whatever.
and then you'll have to go.
Recompile the code.
Well, it's more than just recompiling the code. You'll have to provide an actual dummy implementation. Yeah, exactly. Yep. All right. So I feel better getting this off my chest. I don't know about you guys, but I already feel better. So this is my therapy. Okay. So then there's so that was the two main things that if you're not careful about, if you don't know, so things can go south really fast. Now for this is just a nice cute thing, is that we have verbatim strings and interpolated strings now in C#. So that so this is a verbatim string, right? So instead of putting a new line and tabs or I don't know, all your escape characters, /8 to get it to the bell to go off, then this just goes ahead and does it exactly, formatted exactly as it is, right? So it's a verbatim string. You just put the little @" thing in front of it. Then there's interpolated strings, which other languages had a long time already, but now we finally have this here, right? So it'll just go ahead and instead of doing like a quote here and then plus and then another quote and a plus and then pasting it all together, right? So it does interpolated strings as well. Okay, good. So what if I want an interpolated verbatim string or verbatim interpolated string, right? So until now, that is until 8, there was a very specific order. I think it was $@ or $, not sure, right? You try it, you compile it. If it breaks, you do it the other way, right? If it doesn't, you know you're good. So I think it's $@, but it didn't make any sense. Like why would $@ work and not $? So this is a small thing, big for my sanity. But so they combined the two, right? So now it doesn't matter if you have $@ or $. With 8, it's going to break it. This feature, by the way, is called the owl feature, I think. So now you'll never look at these the same, right? Yeah. So this is the owl feature. So anyway. Okay. So another thing coming is using. So usings, right? So if you wanted to automatically do something when it went out of scope, I don't know, clean up a free database connection, whatever it is. So if it implemented the interface, which used to be a contract, of iDisposable, so then that meant that you were guaranteed that you implemented a disposable function, which then on dispose went ahead and then cleaned up for you. So, okay. Not anymore. So it doesn't have to be an iDisposable as long as it implements disposable, even if it is not of type iDisposable. You can still use usings. All right. As long as it has a dispose method, even if it's not of type iDisposable, it does structural matching. So the compiler goes ahead and goes and checks and says, oh, this has a using, and does it have a dispose method on it? And then
call it whatever I want. I could call it
No, no, you have to call it dispose.
Oh, you have to call it.
So it's still.
just without disposable, or I mean, I guess it's
It used to be that it had to be of type iDisposable, which guarantee that you.
Is this duck typing magic happening?
Oh right, oh right. Only yeah, exactly. Yeah. So if you thought we were getting to like like happier languages, like yeah, no. This is still very statically typed. What?
Like a Danimal.
Yeah. So this is still statically typed. Well, what then? Right. So they don't call it duck typing. Because they prefer to call it structural matching, so that it doesn't sound like they're varying away. But the reason why they did it is because they introduced. You will only get this if you read through the language meeting notices. So if you're ever very tired. So it's because this is little secrets that they don't. So for ref structs, it doesn't have interfaces, but it was still very important to be able to, because that was the whole point. Is you have blocks of memory that you want to go ahead and free up. But you can't have it of iDisposable. So but you can still go ahead and have a dispose function on it that it will then free up.
And there's no other interfaces that needed to be applied to ref struct.
Yeah, that.
Disposable?
Right. It's a newish thing of 7, which just guarantees you get like a block of memory. But anyway, if you're dealing with a span is yes, it's like a span, not really a span. If you use it a lot, if you're dealing low-level hardware stuff too. So we'll touch on span, and it's coming up. All right, default deconstruction. So this is what you can do right now. See, if you write a deconstructor, so I can have an object and then deconstruct it so that it takes this object and then just takes all the values that are defined in the deconstructor and then stuff them into a variable called ID. Then if I don't care whatever this is, so the discard. And then another variable here. All right, so this is what you could do right now. It's not quite like JavaScript. The deconstructor on the. This is the discard. This is existing right now. This is a tuple, right? And the deconstructor will take whatever you said in the deconstructor and stick it into these variables. All right, so this exists right now.
Tuples could access by name.
Right. Yeah.
You still only get that by
Yep. So there's lots of different versions of this. Tuples have different ways of doing this. This is just one. So people were complaining that I can't go ahead and assign these the default value. So if I don't know if this is a number, an int, so then it would be 0. If this is an object, it's going to be null. Now it has to be nullable, but you have to declare it anyway. So people were complaining. So a small thing. So they said, all right. So now if you want to go ahead and put a 0 in here by default and a null in here, so then this is how to do it. I don't think I would ever use this, but I'm just bringing this in so that I could introduce the next couple of topics. All right. The what? The default is a keyword, and it's if I can't scribble on the walls, huh? If I have default parentheses like int, then it'll give me a 0. If a default of an object, it'll give me a null, right? So yes, it's a language construct. What?
So whatever the language.
The language defines, right. And so for objects, the default is null. And for reference type, it depends on the reference type.
Boolean.
It's false, right?
Yeah, exactly. So anyway, this exists in the language now. So this example, this is very common. I mean, not the particular example, but the idiom, right? So I get money, right? And money, there's lots of different kinds of money. Right, so this is, let's say, an abstract class. So money. So if I want to go ahead and see, is this money? I'm expecting wampum, and I want to know if this is the Welk kind of wampum, right? But Welk is the kind of beads that they put. Anyway, can look it up later. So in order to do that, at first I have to test to see, well, did I get back wampum? Because if I got back, I don't know, kesef tzuri, so then it's not going to have beads on it, right? I don't know. So it'll have something else that I could do with it, but it don't have beads. So first I have to go ahead and test to see what type it is. Okay, it's the type I'm expecting, so now I can cast it and then get the beads property on that and see what kind it is. All right, fine. And then once I have that, so now I can go. I know that it will cast okay. I can use the as over here, and so now I know that I'm going to be getting, because I tested over here, I know that I'm going to be getting wampum of type capital W wampum, and I could do wampum stuff, trade it, right? Okay, so this is very common. I don't know, I do this maybe once every day and a half or so. There's something like this, right? You get something back, you test it, fine. All right, so what exists, so can everybody see it, or should I make it really, really big? If you can't see it, how do I? All right. If you can't see, I'll read it to you. If you can't see it, or you might want to come closer. So here I'm getting money, and this the whole block that we saw before is all replaced by this line over here. This line over here does this. I just took the line before, the whole code, and put it on the line on top. So if we read this, it says if money is of type wampum, this exists right now. This is not 8. This is the current language. So if it's of type wampum. Now we're getting more to 8 stuff. So then wampum has a beads property. Check to see if it's welk. If it is, make me a wampum variable and then do wampum stuff, trade it. Okay, so I took the whole entire thing and I was able to very concisely do that short, quick one-liner. I could, if my money is, if I have doubloons, so then go to the pieces property and make me a variable called pieces. And when the pieces are 8, so then do, I don't know, pirate stuff. So loot the pieces. Okay, so that is, it's a very popular, very common idiom. If I have, so this is what is this? This is the property pattern. I could do a little bit more testing on here. This is the recursive pattern. So this says, I don't know, let's say I have something, it's called, I was very tired today, so it's not such a good example, but hopefully you get the gist. So if I have a matbeya, it has some value, right? And then I want to use it for, I don't know, to be paid the master sheni. So I have, I have, I don't know, $1, right? So I could use like 10 cents at a time. So how much chulin do I have still left? And then I have the matbeya.value. I also have the currency, and that has an ID, right? So right now what I have to do is I have to go crawl through the whole entire thing, test it, see if it's there, then go pull all the little pieces out, right? This very one-line concise says if my money is a matbeya, so then go to the value property, and make me a variable called chulin amount off of that. And then the value has like you drilling down. So this is again. So that's why I showed it before. Is again I have the tuple over here that I'm pulling out all the pieces. I have a currency. If I don't care about the other things, maybe the currency has what country it is. I don't know. But if it has like a tzura on it, I don't care. I'm interested in this. So I could like pull all the pieces out and then just throw that into a method that I go ahead and call, right? So
what's the syntax? Everything between the curly brackets evaluates to and
so this everything in the curly brackets is not.
Has to evaluate to true.
So I have two ways. I can either go ahead and test it like this, or if I have a variable, then I could make a variable and stuff the things in here, right? So that's the two syntaxes that are going on over here. So that's why I'm showing both, right? So this in real code like is like a whole page, but I know what I want to do. It's simple, it's straightforward, but it's like just a lot of annoying mechanical stuff. So this takes care of all of it. So that's the recursive pattern, right? So I say I have a value, right? And I'm taking out the whole amount. I have a value, and I have a currency, and that currency has an ID. I'm just showing you how you could drill down, right? So this is the currency, and within the currency, I get the currency ID, right? So it's a lot quicker, easier, more straightforward. I could see if it takes a little getting used to, but once you get used to it, then I could see exactly what's happening.
Why don't you need it?
What? Yeah, that's what I'm doing. I'm flattening it, exactly. I'm going through, I have a very complex structure. I don't need everything. I just need to pull out some pieces. I'm pulling out the pieces that I need and sticking it in here, right? So it could be beautiful and save you lots of trouble. All right. So that is one pattern that is coming. This exists already right now, so showing you what this example is from the legendary John Skeet. So I have this is one implementation, also a popular interview question, just a whiteboard thing, right? So you want to impress them. So here's a way for Fibonacci, right? So it's one, everybody knows, right? 1, 1, 2, okay. And you take the last two and you add them together. So this exists right now. I say case, whatever, I'm discarding the undiscard. And then I say if it's less than 0, so then it doesn't matter, it makes sense. It starts from 1 and moves up. So then just say you gave me garbage. So okay, now if it's 0, so then return this is the definition. If it's 0, give me 0. If it's 1, give me 1. Else, keep on going up and up and up the tree, and then walking back down, right? So it's recursive, so I call myself, right? Fibonacci, I'm calling myself, and just keep on walking up the stack, building my stack, and then walk back down. Okay, so this exists right now. So what's coming is switch expressions. I took all of that, and so it looks more or less the same. So, but right now, what I have is like a list, a collection. No more semicolons. I have commas over here, yeah, and lambdas. So it says when it's of 0, when it's 1. So then do this, do this, do this, right? Okay, so it's exactly the same, just ordered a little bit differently.
Does that mean the switch becomes an object that's like an array type of thing?
Well, wait a second. So this is where you're going to start to get some exciting thing, right? So right now I'm returning the switch, right? So before it was switch on n. Now it's n switch this, all right?
Does it work only with returns, or can you assign?
No, yeah, I could assign it to whatever I want, right? But here I'm just going to it's just a little bit more concise. I could assign it to something and then return that, right? But okay.
Do you have a full body there also, like in brackets in the expression?
Oh yeah. You mean in here? Yeah, these are lambdas. I could put whatever I want. Yeah, to 20, 50 lines. Yeah, I don't recommend it because I recommend you calling something else that has 20, 50 lines, because then it starts to you lose some of the readability, right? So here the point is that I'll show you more an example, 2 slides I think, where you'll see exactly what we're talking about. Okay, so this becomes now I'm returning a switch, right? So now this becomes an expression. It's not just like a glorified jump statement. Just go if else, right? Now it's a thing itself. I'm returning a switch, which then means that I could turn it into a local function. So all I did was clean it up a little bit, and now this function is returning a switch, and I could have this locally within another function, right? So I could turn this now into a local function. So far so good. Any questions? No. Okay. So getting to your question. So I said 2 slides, right? So this is some of the benefits. This is a common way to have a state machine, right? So here I could see exactly how the state machine is going. So here's my current state. Here is where I want to go to, and it's going to go ahead and return a state. So that answer to your question is I have a tuple, right, that is switching on it. So instead of n before a single value, now I have a tuple that I'm switching on. And I say, OK, this is the current state. It's running, and I want to go to suspend. So then return this state, right? And then if it's none of the above, so then obviously I got confused and just bail out. All right, so this is some of the beauty of why you'd want to do this, to go ahead and get your state machine all concise. And I could take all of this and just like put it in a function. I don't have to have like 3 pages of state machines. All right. Any questions on this?
It's like an if statement that has a return value.
It could be made as an if statement that has a return value. This is a little bit cleaner, and the return value is really the switch statement itself. It's like let's pretend that we're in JavaScript right now. So now I'm already happier, and now functions are first class, right? And so now I'm returning like a function that will evaluate to something. So this is if I'm currently running and I want to go to suspend, right? So then my new state is suspend. If my current state is suspended and I want to resume, so then my new state is running. If my state is suspended right now and I want to terminate, just end everything, so then change the state into not running, right? Right. I could do this with like a whole page of if else's, right? This is just more concise and straightforward. Okay, so range and index types. Lots of languages have them. Python, I'm thinking of, right? Yeah, and so then like you go from writing Python and then you go to C# and say, I wish that this had this, so now it does, right? Or it's the best thing since sliced bread, however you want to read the graphic. But so we have an index now, new type index. This is now coming in the language, and so I could have 3 as an index. So I could have my array now. There's lots of changes to the IL. So now if I put in a number, for example, it will then go ahead and change it to it'll cast it as an index, and now go ahead and index this array, pull it out. Yeah, so so I could do this. I could do this explicitly over here. Yeah. Here's something new. So I have this says second from the end. Yeah. So what I could do, so I could do something like this, right? So now, what? You mean like other languages? You want a negative index, right? So you're right. If I had to guess, I'm going to say that the language committee didn't want you to get confused with moving beyond the index bounds. Whatever, I don't know. This is what the language committee thought was least confusing. So there are discussions in their meeting minutes about what exactly this symbol should be. So, but then now there's a new type, a type range, and the little 2 dots over here. So I could do from one index to the other index, make a range of it, and so now if I go ahead and put this in my brackets in the index, so then I get that slice. The dot operator. It's a good question. I didn't think of that. I don't know. That's a good question. Something to think about on the way home. So now I could do like I have a log and I want to pull out like from the 4th incident to second to the end. So now I could take that slice. I could do from the 10th to the end all the way to the end. I could flip it around. I could do from the beginning all the way to some index, right? A range takes 2 indices, yeah. Right, so if I don't do it, then it's implied all the way to the end. If I could have this blank and put something in here. If I just have dot, that just means like give me everything.
So the second example, you're going backwards.
No, I'm going from the 4th to the 2nd to the end.
No, the second one.
I'm going from the 10th to the end, all the way to the end. because I didn't give anything here, so it's implied all the way to the end. Or I could do something like this. So I could do, now this gives me something I could iterate over too. I could do from 5 to 15. Right now, if I want to do this, I would do like a I enumerable.range or something like that. And then it would give me the, right? Here, this is more explicit. I just say, you just give me from 5 to 10, and it'll just keep on churning out 5, 6, 7, 8, all the way to 15. What? Oh, yeah. I was thinking about that also. I don't know. Right. So is this a... Right, he wants to do like 2, 4, 6, 8, right? Not 2, 3, 4, 5. Yeah, I had thought about that. I don't know what the answer is. Async streams. I think this is coming up the end. Async streams are so we have async awaits, right? Currently, right now. So this is now the same thing, but with streams. So I have promises versus observables, right? So promises is the async. At some time later, it's going to be resolved. Everything is going to be there. Observable is like it just keeps on coming in, right? So here's the same thing, and it just keeps on. Whenever the next one is available, just give it to me and move on, right? So underneath the covers, right? We'll see that will be the next slide, right? So like I could implement it this way. I could have a yield return and then just keep on chunking through it, right? But the point here is that there's a new type coming out, async enumerable. It gives me of something that magic happens behind the scenes. The compiler works really, really hard. And whenever it's available, I pick up the end. I don't have to go start worrying about threading and like and wait until something posts. And okay. That's what's going to happen behind the scenes, but I don't have to worry about that. Okay. This is really not such a big deal, but target new expressions. So I don't have a type over here. The compiler is going to assume that this is an int and give me new ints because that's the type that I'm initializing it to. That's not so exciting, but the compiler figures it out. If you do like a var I equals 10, it's going to say, oh, you want an int of, right? Because you're setting it, you're initializing it to 10. 10 is a number, so good, I'll give you numbers. Oh, but what's not available now is now these guys over here, right? So I don't. So I'm saying this is small, but this starts to get a little bit bigger. Is a little bit more. You get a little bit more productivity. It's a little less annoying. It's because right now then I would have to do a new point, right? And then so then that's if it's a complex object, then it really starts to get on your nerves. So the compiler could figure this out. Why do I have to keep on typing it? So now it does.
It's only for basic things like ints, right?
No. If it's complex object, I'm saying that if it's not null, so then go ahead and use it. If it is null, so then use the default value, right? That was way back in the olden days, 1.0. All right? What? Now we have the null. This is not, but now we have the null coalescing operator. So this is the same thing, but just shorthand of say, right? If this is null, so then use this. What do you mean? It exists from 2 to 8, right? Now it says just go ahead and then just say the same thing. If it's null, just use it. Otherwise, give me the default value.
Plus equals.
Exactly. Yeah, exactly. Right. It's annoying. Now it finally has it. It's a small thing, and that's that. All right. Okay.
All right, thank you, Hashi, for stepping up. We did have another quick, about how long, Ellie? About a 10-minute talk scheduled. If anybody's still up for it, what is it? Oh, we can schedule it for a different time. Quick show of hands. Who's interested in hearing a little bit about React hooks? All right. Okay. So. Okay. So we'll hear from Ellie Golding.
Okay. I wasn't expecting such a overwhelming.
Legal Eli. If you gotta go, feel free. It's not hostage over here.
I have a. Hold on.
Yeah, we should have set up the agenda for you. I'm sorry, we were negating your COVID.
Is it? No idea. It's not my computer. No, it's fine.
It's USB 6 or USB.
Anybody cares about that a little bit? I don't do programming. I know nothing about C#, but I'm still said so.
What? You no? Serious? So then I want to use my. Then I should just use my computer, no?
But I was curious. Big picture, how much of what they're doing is just playing catch up with other languages?
See.
So there wasn't that much.
Okay, I'm just gonna use my computer and. Oh no.
They also cleaned up some that already existed.
Stuff
That already existed that they just made it.
Svi.
Again,
Svi.
Some things other languages didn't have.
Oh, there you go, got it.
Okay, so there are a couple of them.
Yeah. For the most part,
Playing catch up.
and these concepts that
Exist.
yeah, exactly.
Thank you. Don't trust the current time.
Yeah.
Okay.
Sometimes it gets stuck.
But then you got to mute it over there.
Yeah, exactly. Is there set up on your laptop before the security stuff ready?
This is a very weird aspect ratio. I'm trying to.
Mirror your display, just change it to mirror.
Fine, yeah. No, I actually was. Okay, doesn't matter. Can everyone see? Okay, it's lightning talk, so I'm going to talk very, very fast. I was hoping to get off the hook but it looks like we saw overwhelming show of hands. Is this guy working? Yeah, it is working. How many people here work in React on a show of hands? Okay, good. How many people? What you used to? And anybody look at hooks yet? Play around with them? No one. Oh boy, this is gonna be hard. Okay. Who here familiar with like the patterns like higher order components, render props, and stuff like that? Okay, almost everybody. Okay, so we're just gonna run through it quickly, basically. We're just gonna take a quick trip down memory lane. So this is actually the actual code that I gave from my React talk 5 years ago here, not here, in 500 River Avenue. Create class, who remembers that? But this is the React that we know and love, that it gave us everything, local state, and one-way data flow, re-rendering, and stuff like that. But the biggest problem that we always had with React was there was no primitives for shearing component logic. There was one. It was called mixins. This existed a long time ago, back in the create class days. But very quickly, people didn't like that. And Danny right away said, yeah, mixins are dead. Long live composition. I think he just said this because everyone got very excited about functional programming, so they wanted to use buzzwords like composition and stuff like that. But then it got even worse. Like mixins considered harmful. Can't use mixins. So the next thing everyone started paying attention to this, just that Sebastian Mark Bajay, whatever it did. And all of a sudden, this new thing called higher order components came around. And basically, the idea with the higher order component, it's a horrible name because it's not really a higher order component. It's like a higher order function that makes a component, really. Well, the component that it returns is maybe a higher order component. But basically, you'll have this thing called enhance, which is a function that will take a component that will return a new class that will actually render the component, but it can maintain its own state and pass the state in as props to the new component. And then you can just create it by using enhance my component, and then you have access to my data, which is the state from over here. So this was one pattern that people did, and eventually it became so popular that it actually made it to the React docs, and higher order components was like an official thing. But then, oh man, this guy came along, and he spoke by ReactConf, and he introduced this, like everyone looked at this and said, like, what in the world is this? But eventually they gave it a name, and they called the function as child components. And the basic idea is that children can be a function, because it could be any, it could be any JavaScript thingy. So basically you can render something like this, where you pass in, right, you open up your curly, so you go into JavaScript land, interpolation land, you just pass in a lambda over there, and you get something. What's that something? Well, that something is gonna be whatever my component, it could have its own state, and it can pass it in to the function, and that way you have access to this component state within the rendering thing. So, right, the sprach was you give me rendering back to over here. So, but still, people still liked higher order functions like much better So this function as children didn't really take off until some people started making trouble, and then it got worse. Michael Jackson said, Come fight me. He took this very seriously, and then he took it to the next level, and he wrote an article, and he renamed it to render props because he wanted to make an even bigger deal out of it. Then he opened the PR on React and said, add render props to the thing. His first one was closed, the second one was finally merged, and eventually render props is finally in the React doc. So we have hierarchy components and render props, and those are basically the two patterns, if you may, for shearing stateful component logic in React. So, but there's a couple of problems with it. They're not primitives. They're not part of the language itself. These are patterns that the community has adopted. There are problems with hierarchy components and render props. First of all, it requires you to restructure your components, and you end up getting wrapper hell. If you don't know what it means, you basically, when you have render props, you could just imagine you'll have components rendering components that have more render props. There's another render prop, and we're back to callback hell, and that's like very, very not good. So we really need a better primitive part of the language for sharing stateful logic, and that's what hooks is all about. There's also another aspect that hooks, so that's one problem. There's also another aspect of side effects. Side effects is stuff like fetching data or subscribing to WebSockets or anything, accessing the DOM, all the side effecty stuff. Right, call API, subscribe to events. So we know where we do them. We do them in lifecycle methods. Lifecycle methods require us to use class components. They're complex because right, you have component did mount, you have component did update, you have component will mount. Shai, I'm talking. Shai, you said you want to know this stuff. Right? And what happens is that you get unrelated code gets combined into a single method because you need everything that you're going to do on mount. Even if it's not related, you only have one place to do it. But code that changes together gets split together because you have, if you're having the subscription that you have to subscribe to and then unsubscribe, one's going to be in component will unmount, did mount, and one could be in unmount. So you have unrelated code gets combined to a single method, code that changes splits apart. So this is not cool. So welcome to hooks, and this is what hooks is all about. It's coming in React. Right now it's in alpha. So of course it's in production in qualitybath.com. It's not yet. We have a PR and it's not in there yet. So let's talk about hooks. So the first thing that hooks does, what did you say? Back up. Yeah. Okay. So here we have a good old thing. This is like, oh, it's not even working. Oh, it is working. You can't really see it, but basically the button's disabled if there's no state. But basically, this is a regular class component. It has state. It's a little string. It has a form with an input. The input's value on change is we're setting the state, as it changes. The button will be disabled if there is no input, and then when you submit the form, it alerts it and blows it out. This is a very complex app that's going to make lots of money, or not. So let's make this. I'm going to make it a little. Can you see? I'm going to make it a little smaller if that's okay, because it's too big for me. I can slide over which thing? This guy. Yeah. You don't need that much space for my input. Oh, I guess not. Okay, fine. What? I'll make you full screen. How do you make it full screen? It's not my computer, so. Oh man, how do you know these things? You still use a Mac? Didn't work. I'm sorry. It's because it's Mojave. I don't know. Whatever. And it's the touch bar. Touch bar. Okay. So first we're gonna change this into a function. So that's the first thing we're gonna do. Change it to a function. It's not gonna extend component, so it's not a class component anymore. So it's just gonna be a regular function. So we're gonna comment. Oh. Am I not in Vim mode? Oh, because the touch bar doesn't know. Okay, I'm sorry. We're just going to take a break for a second. Yeah, I'm in Vim mode. Thank you. There we go. Ah, now I can live. What in the fuck? I'm telling you, this touch bar thing has to go with, like, I don't know. We good?
This part's more
There we go. Okay, comment this out and delete that. And delete that, and save it. Very good. So now we have a function component that's just returning. What? I don't need an arrow. I don't have a reference to this anymore, so that's why I'm not compiling. But no, we're good. We have a function. So the first thing is, first of all, we don't have this handle submit anymore. We don't have this in functions anymore. I mean, you do have this, but don't use it. We also don't have state anymore. So where's the state going to come from? So that's going to be the first thing we're going to do. First thing we're going to do is we need to replace our state. You see, we have state over here. We got to replace it. How are we going to replace it? So everyone look very carefully. Okay, we're going to have an input. And we're going to have a change input. Change input. and we are going to use state. What? Yep, that's right. Use state is a hook. We're going to import it from React. Okay, it's a function that you call, and you give it a default state value. And this syntax, everyone's familiar? Array destructuring. Okay, so use state returns an array. The first is going to be the value of the state, and the second one's going to be an update. So we have no more this.set state anymore. So bye-bye this.set state. Bye-bye. We're going to say goodbye to you. And we're just going to change the input. And you don't have to change, you don't have to pass in an object anymore because you're only changing one piece of state at a time. So you actually just pass that in. And now handle submit. You see, I don't have, what? Shh, touch bar. Sorry. So this, instead, is just going to be a regular good old method. Handle submit. And we don't have this.input anymore. And I think we're done. Oh, we're done. So look at this. So we changed to a function. Let's get some prettier working over here. There we go. Line 11 is this.set state. You're right. So we're just going to cut and paste. No, just. And what are we doing? Empty string. I can't see. Ooh, style. What? I see. I need my computer back, but my computer is doing the live stream for the 2 people that are watching. 4. Whatever. What am I doing? Background color. You should be able to see that. It's gray. You can't. Okay. Whatever. I don't have time for that. No, seriously, because Dylan has to. We have to minus 9 o'clock. Right. But basically, this is the idea of a hook. Where basically you could use state. You no longer need a class component anymore. You have this functional way to have that your function. And let's say you have multiple pieces of state. Come on, escape. Right? Let's say you could have multiple pieces of state, and you could just change the names, because this is array destruction. You could use whatever name you want. And if you want it a little more complex, you could use. There's a bunch of other hooks you could use. You could use reducer if you want to update your state using like a Redux style type of thing. You could like do reducers. That's just about it with state. So that is state. Okay. That's so funny. I know. Okay. So we're gonna move on. So that's state. So this is just like the very basic hello world of thing. But let's go back to the Brave. Yeah. Okay. So now we're really gonna talk about hooks. Okay. So this is my responsive image component. This is my responsive image component. It's a responsive image. You pass in a bunch of images. Is this even going to work? Oh my gosh, this is not going to work. See, it's responsive, but it's beautiful. Okay, now how does it work? So obviously, to have a responsive image, you have to be listening to the. This is. What? Yeah, it's just a picture element. Never do this yourself. Like use the platform. I can't believe I just said that. Whatever. Use the platform. Don't re-implement responsive images unless you have to. But obviously, responsive image on component in and out, we're going to listen to the window for the resize, and then on resize, we're just going to set state to the window inner width. Pretty straightforward, right? But like we said before, same code, 2 different places. Component will amount. We have to remove the event listener. That's supposed to be this. This dot on resize. I just had a memory leak, in case anyone cares. Actually, no, I just had code that didn't compile. But basically, so that's how we're gonna do that. So what? So let's get started. I don't want a class component. I want a function. I like functions. Let's get rid of all this. Oh, I actually, believe it or not, I was given some advice this morning. This is the second time today that I'm giving this talk, to have it prepared. Okay, because that way you don't have to watch me type. So here's what we're going to do. It's almost prepared. But we started again with useState. So now we have a function. That's the responsive image. It's taking in props. Let's get some useState in here, because apparently it's missing. Now it's still missing. useState. I'm almost finished. Promise. So we have our responsive image, but it's not really working anymore. because we don't have component didn't mount anymore because it's missing because we're in a function component. So how in the world do we do this side effect of listening to an event on the window? We're going to use effect. And that's another hook. Use effect. Use effect is where you put all your effects, ironically enough. Okay, so we use effect, and it's a function that gets called on every render. Every render, every time your state will change, it will get called. And then there's two parts to use effect. First, it will get called, so we are going to do that. But the problem is there's no more this anymore. So on resize is going to be, on resize like we saw before, is not going to be, we're going to update our width. This is going to have to be a regular variable. On resize, so good. Problem is, now we have a memory leak because we're not unsubscribing. So we will return from the effect what we call a cleanup. And we're done. What did we do? We're almost done. I'll explain what that does in a second. But we should be good. We should be in business with hook. It's working. So now we have state. Let's get rid of this. See, this is not my computer. Sorry. Here we go. So now we have, so use state like we saw before. It defaults to the width. We could update it with this little inline function over here. Yes, it gets recreated on every single render. It's not a problem. And if it's a problem, there's a hook for that. Right? For those of you who are so concerned, you know, so yeah, we're going to use, you're so concerned about not, you know, about your memory usage in the browser, which is really not a problem. So fine. Fine. What? That didn't do anything? No, oh, you have to change. I have to pass in. I'm sorry. I said fine too early? Fine. Okay. There's another hook for that. There's use memo. But that's just for the OCD people. Here, so what's use effect? Use effect has to run on every render, and it'll get run, and the cleanup will get run before the next render. Obviously, that's silly in this case because you really only have to bind it. You only need to bind the event once and root the event once. So you could pass in stuff. You could pass in any state variable over here, and it will only get run, or any variable really. It could be a prop. It could be a prop as well. Yeah, any variable, and then the effect will only run on the next render. It will only rerun if that changes. If you never want it to run a second time, you could pass in an empty array, and that's basically saying on mount and on unmount. So on mount we are going to listen. On unmount we are going to remove, and you know, and that's it. And now, so now we have a function component, and now, but it gets even better. This has nothing to do with responsive images. It has to do with listening to the window size, right? So why in the world do I need to have it here? What if, right, we're back to our original problem of code reuse. What happens if I want a different, what happens if I want to say the, you know, over here, I want to say the window, the width, I want to announce to the world, you know, what it is. So in the old way, you'd make this into a hardware component, or you'd use a render prop, or you'd use any other fun thing, buzzword. But what if I'd rather just use window width? I think so. Yeah, we'll do that. We'll use it. And what are we going to return from there? We're going to return the width. Okay? We're going to return the width. Where's the width going to come from? I'll give you a hint. Ba-dump.